Okay, so officially I welcome you to semester 4. You already had a lecture, but as your class advisor, I welcome you to semester 4. And this time I'm teaching the subject microprocessors. Okay, and do interact in between, give answers, respond. Okay, now uh, let's begin by a brief introduction to microprocessors today. So the very first question is, why are we learning this subject? I asked the same question in the first session when I was taking data structures. Why are we learning the subject? So I'm asking this question again. Why are we learning microprocessor? If you remember, we had discussed the course objectives, the course outcomes, all those things in the very first session, right? I'm asking the same question again. Why are we learning microprocessors? Why am I asking this question? Because it is the answer to this question which is going to arouse your interest in this subject. And it is very, it makes sense if you understand why you are learning a particular subject or why that particular subject is there as part of your syllabus. Come on, tell me, why are we learning microprocessors? It doesn't matter if you go wrong, give your inputs.
Ma'am, to learn about the arithmetic and logic regarding data processing.
Okay, very good. Any other
Uh,
inputs?
it is the most basic part of computer as microprocessor kits are the were the first kind of computer we can say.
Okay, who gave the answer? I'm not able to make out.
Vivek.
Vivek, Gupta Vivek, okay. Okay. Any other input? So Vivek told a very good point. As a computer engineer, you are supposed to, a computer is a combination of hardware and software, right? So you're supposed to know the hardware part as well. Any other inputs? Okay. Now you tell me, uh, what is the first thing that comes to your mind when you say microprocessor? Or when you look around,
I see.
But the chips which run the computer, processors.
okay, so when you look around, what all devices can you identify where you have these microprocessors?
Laptops, phones.
Laptops, phones, computers, right? That is normally the very first thing that comes into your mind into everybody's mind when we say the term microprocessor, right? Now look around. Just look around the room where you're sitting. You might be having a fan. You might be having a tube light in your room. So does a fan have a microprocessor in it? Does your fan have a microprocessor in it? Come on.
I guess no.
No. Okay. What about your tube light?
Yes, ma'am. I think in tube light.
Okay, Vivek is saying a tube light has a microprocessor. Okay, I'm not negating it right now. We'll come back to it. Any other device? Can you identify any other device around you which has a microprocessor apart from your computer, laptops, and mobile phones in your home?
Ma'am, TVs have.
TV is there. Okay, very good. Who gave the answer?
Ma'am, Anirudh.
Anirudh. Fale Anirudh. Okay, what are the other devices?
Ma'am, everything like calculators also have microprocessor.
Okay, what about your TV remote?
They also have microprocessors.
What about your smart TVs, your smart refrigerators? Do they
Yes,
have?
ma'am. Yes, ma'am. Yes, ma'am.
Yes, they also have.
Is it microprocessor or something else?
Ma'am, it's a microcontrol device in remote control and all.
Okay, it's a mic. Who said the answer?
Ma'am, Aniruddha.
Anirudh. Okay. So Anirudh is saying it might be a microcontroller, right? Not a microprocessor, maybe a microcontroller. Okay. Let's step out of your home. Everybody might be having elevators, lift in your building, right? So
Yes, ma'am.
does your lift have a microprocessor? I mean, does it have a microprocessor or microcontroller?
Yes, ma'am.
Yes, ma'am. It will have, yes.
It will have. Yes. Okay. So what is the meaning of that? Okay, you said your fan does not have a microprocessor, but your building lift has a microprocessor or a microcontroller, whatever it is. So, what does it simply imply? Why your fan doesn't require a microprocessor?
Ma'am, because we turn on the switch, electricity flows, and just the motor runs. And in
Oh,
lift, we have controls. Like if we press button 5, then it goes to the fifth floor. That requires a controller or processor.
yes, that means there's no logic or there's no data processing operations happening inside a fan. Okay, even in a tube light, somebody said tube light has a microprocessor. A tube light, and if it's a normal tube light, it doesn't have a microprocessor. So your fans, tube lights, all those don't require a microprocessor because there's no programming, there's no logic happening, right? You switch it on, it rotates, it gives you air, right? It circulates air. You switch it off, it becomes, it gets off. That's it. There's no programming involved. But when it comes to your building elevator or your TV remote or say your microwave where you have timing or your smart washing machine, refrigerator, when it comes to all these devices, there's some sort of programming, timing happening, right? That means what? Wherever you have this concept of programming, you will have a MUPI around in whichever device it is. Huh? So that means in as a computer science engineer, whatever programs you're going to write, okay, whatever programs you have written so far, and wherever it involves logic, whatever programs you have written so far, or all the programs that you're going to eventually write in future, they are all going to be a executed on a microprocessor or a microcontroller, executed by a microprocessor or microcontroller. Okay, so that gives you one simple reason why you need to learn this subject, right? Because when you look around you, you can identify so many devices which uses data processing or logic, and wherever you have this data processing or logic happening, you will either have a microprocessor or a microcontroller which is being used to execute the programs. For example, okay, to make it more specific, suppose you step out of your building and then you walk, you are right now on the road, uh, you can see the traffic signals, right? So does your traffic signals have any programming involved? Does traffic signals have any programming involved?
A timer.
Yes, you have a timer, right? Red, green, orange, or yellow, right? There is a timer involved. That means there is some programming involved. So that means there also you have either a microprocessor or a microcontroller. If you walk and you go to the station, you get into a train, or on the station, you can see so many indicators. Even inside the train, you can see indicators which display the next arrival stop, right? Do they involve microprocessors or microcontrollers? Obviously, yes, right? Because there is some sort of logic happening in the background. So, in all devices where you have these logic or programming happening, you have a microprocessor or a microcontroller. Okay. Now, suppose you're going to the market to buy a computer for you. Okay, a laptop or a computer for yourself. So, what would be your specifications? What would be the specification of your microprocessor? What would be the specification of your microprocessor which you want for your laptop?
Intel or AMD, like that.
Yes. Either Intel, I mean, if you can afford it, you might go for Intel i7 or a higher version. Or if you're familiar with the AMD family, you might opt for an AMD processor or Ryzen or something like that, right? So that means as a computer science engineer, you need to be aware of the fundamental concepts of microprocessor, because any program that you're going to write in future is going to get executed on a microprocessor or a microcontroller. Okay, so that's my first question. I've given one answer to it. Now there's also another angle of looking at it. To make that clear, let me ask you one more question. Okay, now we are in this 21st century now. Okay, so in this subject, you're going to learn microprocessor using 8086. Okay, using 8086 processor. We're not going to learn Intel i5, i3, or i7. We're learning the subject using 8086, not even 8085. Okay, when I was learning the subject, uh, I learned the subject based on 8085. For you now it's 8086. Now my question is, why 8086, and why not all these modern processors? Why are we learning this subject?
Ma'am, because it has less pins, so it is easier to understand.
Okay, less number of pins. Okay, so it is easy to understand. Any other reason?
It was the basic processor, and all modern processors are derived from these processors. So to understand the basics of processors, we might study first the beginning. Like we first studied C, then studied Java and other languages. Like
Okay, very good. That means it's a basic processor. Basic in the sense, 8086 is an 8085 is an 8-bit processor, and 8086 is a 16-bit processor. All the modern processors that you have nowadays, they are 32 or 64-bit processors, right? And we are learning the subject using an 16-bit processor. Now, there's another angle to this question, another very important aspect. Okay, that is, when you looked around, okay, we identified so many devices which were using, which are using either microprocessors or microcontrollers, right? Now all these devices don't have a 32-bit or they don't have a 64-bit microprocessor or microcontroller in them, right? So for majority of the devices, for the low end applications which have a huge market in comparison to your to your computers, laptops, and mobile phones, okay, you won't believe, 90 percentage of the market share, okay, I'm talking about the market share of microprocessors, only 10 percentage of them is attributed to this high-end processors like 32-bit or 64-bit processors. 90 percentage of the market share is captured or is dominated by these small microprocessors, these basic microprocessors like 8085, 86. 8085 and 86 are actually not used right now, but they are used with different other trade numbers. They're no longer manufactured by Intel as of now, but Intel has actually given out the license, outsourced the license for manufacturing these low end microprocessors to other companies. Okay, so they are used with other trade numbers. So when you see the whole consumer market, most major, the 90 percentage of the market share is for these small processors, not is it's not occupied by these high end 32-bit 64-bit processors. And that is another reason, that is one of the main reason why we are learning this subject using these using this 16-bit microprocessor, which is 8086. Already Vivek has given another, Vivek and one more person has given another answer, right? Which is also valid, that you are learning, you are learning learning the subject using a microprocessor with less number of pins, or it's a basic microprocessor, so you'll be able to better comprehend the subject. That is one reason. Okay, another reason is because what I've said, 90 percentage of the market share is dominated by these low end microprocessors. That means it's mainly used for industrial automation, industrial control, industrial automation, consumer electronics. Now, a major share of the low end applications including industrial control, is dominated by the small basic 8-bit and 16-bit microprocessors, because you don't even need, see, if you consider your TV remote or your uh, lift lift or small appliances like your electronic shaving machine which you use, or your you can slide your windows of your car, right? All those applications have small low end, the basic 8-bit or 16-bit microprocessors. They don't require a 32-bit or 64-bit microprocessor, because they are not doing any number crunching operations, right? Your computer is doing a lot of number crunching, data processing operations, but all these small devices, they are not doing any number crunching operations. So for them, the small 8-bit, 16-bit microprocessors are sufficient. And there's also this cost performance trade off, right? For these small devices, you can't afford to have a 64-bit microprocessor, because there is that cost factor also, right? So the thing is that these small 8-bit, 16-bit microprocessors have a larger market share, and they are also cheaper cheaper in terms of cost, as well as in terms of power consumption also. And that is another reason why we are learning the subject using 8-bit or 16-bit microprocessor. One thing is, it is easy to comprehend. The another reason is this. Okay, are you all listening?
Yes, ma'am.
Okay, so we have right now, just a minute, we have right now answered two questions. Okay, one is why we are learning this subject, and another is that why we are learning this subject using basic 8-bit or 16-bit microprocessors or microcontrollers. Okay, so we have discussed the answer to two questions. Now, let me ask you another question. Okay, why teach 8086 itself instead of 8085? Okay, I told you we are learning the subject using 8086, not 8085. I told you when I was learning, I learned the subject using 8085. Does anybody know the answer to this question? I mean, if you have any, if anybody has idea about
Ma'am,
80,
maybe the new processors are not based on 8085.
okay, any other answers? Any other answers? Okay, no other answer. Okay. See, actually, which microprocessor you are using to learn this particular subject doesn't matter whether it's 8085 or 8086. 8085 is 8-bit microprocessor, 8086 is 16-bit microprocessor. To understand this subject, you need a microprocessor which has which is small, I mean in terms of the number of pins, or which is a small basic microprocessor with a with an adequate instruction set. Okay, that is your requirement for learning this subject, a small basic microprocessor which might be 8-bit or 16-bit with adequate instruction set. That much is enough to understand the subject. See, in the previous semester you had the subject about digital logic and computer architecture, right? There you had the, I mean, even though you might not have actually performed the experiments, but to learn and or gates and all, we use the small basic ICs only to learn the working of the and or gates or XOR, all those gates, right? We don't use a very complex VLSI circuit to understand the working of and or gates. A small chip is sufficient. Similarly here, to understand the concepts of a microprocessor, any microprocessor will do. Okay, any basic microprocessor with a sufficient adequate with an adequate instruction set is sufficient. So it's okay whether it's 8085 or 8086. Both 8085 and 8086 are not actually manufactured by Intel now, but as I said, Intel is outsourced the manufacturing license of such small microprocessors to other companies. So they are manufactured not in that name, not in the name of 8085 or 8086, but with other trade numbers. These microprocessors are manufactured even now, and they are being used wide scale. As I said, a huge market in industrial control and consumer electronics. Okay. Whereas these high-end microprocessors are mainly used in computers, laptops, mobile phones, workstations, and other very complicated applications like military, hardware, avionics. Only they require these high-end microprocessors. Other small consumer electronics don't even require, and there's this cost performance trade-off. Okay, so 8086 is a basic microprocessor. It's a 16-bit microprocessor with an adequate instruction set, and it does have some additional features when you compare it with 8085. Okay, so we are learning the subject using 8086, and we'll uh, no when we start learning the subject, you'll be able to identify what are the features that are there in 8086 and which are not there in 8085. Okay, so we just now answered three questions. Now let me ask you another question. Mm, do you know the evolution of microprocessor? Do you know which microprocessor, which is the first commercially successful microprocessor? Anybody knows?
Ma'am, 8080.
8080. Okay, very good. Okay, just a minute. Let me just open the slide. Give me a second. Okay, 8080 is not the 8080 actually came before 8085, but it is not the first commercially successful microprocessor. Okay,
Ma'am,
the
Intel
first
4004.
4004.
no, the first I mean the first commercially successful microprocessor you can say is 8085. Okay, there were many attempts before that also, but when you say commercially successful, it has a specific meaning, right? So the first commercially successful microprocessor is 8085. So if you see the evolution of microprocessors, we'll start with 8085. There were 8080 and all came before that, but they were not that commercially successful. Okay, so we had this 8085, then we had this 8086, and then came 80186, then came 80286, 80386, 80486, then came 80586. 80586 also has another name. Does anybody know that name? 80586 का और एक पॉपुलर नाम है, किसी को पता है? सुना है? नहीं सुना है?
Pentium.
Pentium 1. Okay, 80586 is also called as Pentium 1. Okay, and this whole thing is called as the 80x86 family. Okay, 80x86 family, or it's simply also called as the x86 family. So 80586 is called as the Pentium, is also called as the Pentium 1 processor. Then we have this Pentium 2, then we have this Pentium 3, then we had Pentium 4. उसके बाद कौन सा आया? उसके बाद कौन सा आया? Do you know this processor? I think you might not be familiar, because when I was studying around in 2006, the very first computer which I purchased had this processor in it. This is, you might have heard of it, Core 2 Duo. You've heard of this, right?
Yes, ma'am.
Yes. उसके बाद जाके जाके बहुत variants आए, and then you have this latest i7 and higher versions, right? Core family, Core i family, i7. Okay, so this is kind of the timeline of the evolution of microprocessors. So there were many attempts before 8085 also, but first commercially successful. That is why I told that these 8085 86 microprocessors have even now have a very large market share. 90% of the market share is for these low end in the sense the 8-bit or 16-bit microprocessors. So 8085 is an 8-bit microprocessor, 8086 is a 16-bit microprocessor. Now what do you mean by 8-bit or 16-bit? 8-bit means 8-bit can be processed at a time. 16-bit means 16 bits can be processed at a time. We'll come to that later on. But this is the evolution or timeline of the evolution of microprocessors. Okay, so 80586 is called as Pentium 1, and it is after this Pentium 1 that people started realizing the power of microprocessors. It is after this that we have that what do you say boom of multimedia and internet happened around this time after Pentium 1. That is when people realized the processing capacity of microprocessors, and these computers became an object in almost every household. It is after this Pentium 1 that boom happened. Okay, so this is the evolution, and we are learning this subject using this microprocessor 8086. Okay, 8086 has some additional features than 8085, and we'll learn this as we proceed through the subject. Okay, now okay. So far we have answered some questions. Why the subject is important? As a computer science graduate, you need to understand both software and hardware, right? Microprocessor is like the brain of your computer, right? So it is important for you to understand the subject. Another thing is that when you look around, you can see so many devices that are using microprocessors and microcontrollers. So every device that has programming involved, that has logic involved, has a microprocessor, right? So as a computer science graduate, in future, you're going to write a lot of programs. You've already written so many programs, and for all the programs that you're going to eventually write, all of them are going to be executed on a microprocessor. So only if you understand how a microprocessor works, or you understand the background concepts, you will be able to write better programs, right? So you need to write better programs. So this subject is very important, and that is one of the reason the subject is there in your syllabus, and we are learning the subject using 8086 microprocessor. Now why 8086 microprocessor? Bigger is always not better, right? Bigger is not always the best. Bigger means the 32-bit or 64-bit microprocessors, we are not using that to learn the subject, because see, whether it is 1990 or 2000 or 2020, when you go to learn when you go to learn English, when a child learns English, it always starts with ABC only, right? In whichever generation you are, same thing applies here also. To comprehend this subject at the introductory level, you need to learn the subject using a basic 8-bit or 16-bit microprocessor. So at the introductory level, in order to comprehend this subject, we need to choose a small basic microprocessor only. Right? We cannot, even though the concepts are similar, see, if you learn the subject using 8086, you will be able to easily transfer the concepts to other microprocessors. When you make an attempt to learn other microprocessors or microcontrollers, you will find it easy, because whatever concepts you are learning in 8086, all those concepts are transferable. So you will be able to easily adapt in learning a new microprocessor. When you are in a new environment, you'll be able to easily adapt yourselves, because the same knowledge applies there also. Okay. And then, as I told, when you consider the whole microprocessor market, a major share is dominated by these smaller microprocessors, okay, 8-bit or 16-bit microprocessors. Even though they are not known or manufactured with the same trade number, but they are manufactured and used much more than the 32-bit or 64-bit microprocessors. They are used with different other trade numbers. So if you're interested, you can just go and Google up what are the current trade numbers of these 8-bit or 16-bit microprocessors which are used in consumer electronics and industrial control. Okay. So that is what we have discussed till now. Now let's go to the course objectives. Okay. So I hope you got some idea about why we are learning the subject and why we are learning it using 8086. Yes or no?
Yes, ma'am.
Okay.
Yes, ma'am.
Now look at the course objectives. These are the course objectives as given in your syllabus. Okay. Course objectives are written from a teacher point of view, and course outcomes are written from a student point, from a learner centric point of view. Okay. So this is kind of the objective which I'm supposed to achieve, to equip students with the fundamental knowledge and basic technical competence in the field of microprocessors, to emphasize on instruction set and logic to build assembly language programs, to prepare students for higher processor architectures and embedded systems. Higher processors means uh, the higher ones, the 32-bit or 64-bit Intel microprocessors. Okay. See, these higher processors have very complex architecture and they have very huge instruction set. We cannot, as a beginner, you will not be able to comprehend that level of complexity, and you will not be able to learn that whole instruction set. This 8085, 86 and all have a very small architecture. I mean, they have a less complex architecture and they have a smaller instruction set. So you will be able to easily comprehend. But once you learn that small basic architecture and instruction set, you will be able to understand the working of the higher processors. Okay. So these are the course objectives. Course outcomes are defined from a learner point of view. Okay, so this is for you. So if you remember, we had discussed some course outcomes when we were learning data structures also. And then in the end, you all have done a course exit survey also, right? You remember filling a course exit survey for all subjects on your Moodle course page?
Yes, ma'am.
Yes.
Yes, ma'am.
You might have blindly given some rating over there, but what is the purpose of that course exit survey? That course exit survey you have to actually read, comprehend, and then give the rating. That course exit survey is actually measuring how much of the course outcomes you have as a student after completing that course. How much of the course outcomes which were initially defined you were actually able to achieve. मतलब वो सब्जेक्ट पढ़ने के बाद जो शुरुआत में ये कोर्स आउटकम्स डिफाइन किए हुए हैं वो कितना तक आप attain kar paye. That is the purpose of a course exit survey. So in the course exit survey you might have seen these course outcome statements, and then for that every statement you have this excellent, average, good, right? You might have given that feedback. So what is the feedback that you're giving? The feedback is your feedback, how much you have understood, whether you have, say, the first outcome as describe core concepts of 8086 microprocessor. So at the end of the sem, you'll get a course exit survey with these statements, okay? And then you'll be given the rating. So if you're giving excellent rating to that first course outcome, it means you know the core concepts of 8086 microprocessor. So it's actually a measurement. Course exit survey is a measurement of your course outcomes. Okay, so next time when you're doing, don't simply blindly give some rating, read the statements, analyze how much you have understood, analyze how much attention you have paid to the lectures, analyze if you get an opportunity to work in such a role. See, there are, apart from being a programmer, you have other opportunities. You see, when if you go in this line, in the hardware line, you will be able to become a system programmer, system analyst, chip level designers. There are so many associated roles in these companies like Intel, Motorola, etc. You will have hardware positions. So programming is not the only job that you can take up. So if you are interested in this line, you can pursue a career in this hardware line also. Okay. Now, so the first one is described. So these are as defined in your syllabus. I'll be changing these course outcomes later on, and then I'll show you the updated course outcomes also. But as of now, let's discuss these course outcomes. First one, describe core concepts of 8086 microprocessor. Okay. So in the first module, so you have 6 modules or 6 chapters in your syllabus. In the first module, you will be learning about 8086 processor, architecture, uska pin diagram, uh, the features like memory segmentation, all those things you'll be learning, modes of 8086, all this you will be learning in the first module. So once you learn that, you will be able to describe the core concepts. So these core concepts are actually similar in all higher processors also. Second outcome is interpret the instructions of 8086 and write assembly and mixed language programs. Okay. Assembly, you will be able to, once you learn the instruction set, you will be able to write assembly language programs and another domain of programming which is called as mixed language programming. Mixed language programming is a combination of a higher level language and assembly programming. जैसे आप C में आप कोड लिखोगे और C के कोड के अंदर आप assembly programming लिखोगे. For example, okay, if I'm writing a mixed language program to to manipulate the cursor movement. Cursor रहता है ना अपना mouse का cursor. If I want to write a program to manipulate the cursor movement, मतलब अगर depending upon my program, depending upon the input that I'm giving, the cursor should move left, the cursor should move right, up, down. If I want to write such a program, I can go for a mixed language program. I can write the code in C and then I can write the assembly language code. Which includes a lot of BIOS interrupts and all. I'll be including the embedding that assembly language code in that C program. Okay, that is called as mixed language programming. When you are embedding assembly programming in a higher level language. So in the second module, you are learning the instruction set and then you are learning how to write assembly language programs. Okay, so that is what is there in the second module. So that is the second course outcome. Third is identifying the specifications of peripheral chips. Now, peripheral chips means apart from 8086, you will be learning about several peripheral chips, like certain chips which are used to perform timers, which do the task of timer. आपने देखा होगा वॉशिंग मशीन या माइक्रोवेव, दोज डिवाइसेस हैव टाइमर्स, राइट. सो माइक्रो कंट्रोलर के साथ वहाँ टाइमिंग जनरेट करने के लिए दूसरा भी एडिशनल चिप्स यूज होता है. सच चिप्स आर कॉल्ड एज पेरिफेरल चिप्स. सो यू आर लर्निंग द स्पेसिफिकेशंस ऑफ सर्टेन पेरिफेरल चिप्स आल्सो. ओके, समझ में आया ना पेरिफेरल चिप मतलब क्या है? आर यू ऑल देयर? हाँ.
Yes.
Okay, don't sit and sleep. I'm talking so much to arouse your interest in the subject. Huh? Now, next outcome is design 8086 based system using memory and peripheral chips. तो यहाँ fourth module में आप designing सीख रहे हो. How can you like given these many number of chips, you want to design a 8086 based system with this much memory and this much peripheral chips. So given a certain set of certain requirement, how do you work within that constraint? How do you design such an 8086 based system? So here you are learning memory interfacing and designing in this fourth module. Then in the fifth module, so fourth module, in third module you are learning memory and peripheral interfacing. In fourth module you are learning about 80386 processor. Okay, 80386, 80386, 486, 586. 586 is Pentium 1. So chapter 5 में आप Pentium 1 सीख रहे हो. Chapter 4 में 386, chapter 5 में Pentium processor, and in chapter 6 you will be learning Pentium 4 and several advanced features like hyperthreading, superscalar architecture. So there are several concepts like superscalar architecture, hyperthreading and all, which are the reason for your modern processors being so fast and efficient. So you're learning all those technologies which are responsible for making your processor so fast and efficient in terms of performance. So you will be learning the architecture of advanced processors like 386. Advanced in the sense, when you compare it with 8086, 386, Pentium 1, Pentium 4 and all are advanced. Okay, so you will be learning the architecture of advanced processors like 386 and Pentium 1, Pentium 4 and all. And in the last module, you will be learning few technologies which are responsible for the better performance or the efficiency of your current processors, advanced processors. So this is what is there in your syllabus. So you can see here, this is your syllabus. How many of you have gone through the syllabus? How many of you have gone through the syllabus? No one? नहीं किया है? अब नहीं करोगे तो कब करोगे? हाँ? How many years you are going to spend studying? 4 and 6. 4 plus 2, maximum 6. Right? So you should have that interest, na? What is there in the subject? Just go through the syllabus. So this is your first module where you have the fundamental concepts of 8086, core concepts of 8086, pin diagram, banking, segmentation, demultiplexing, interrupt structure. Okay, might look like theoretical, but it's very, very interesting to learn. Okay, so the subject, even though from the syllabus it might appear to be a theoretical subject, but it is very interesting. You don't have to by heart anything if you understand and learn. Second module is about programming. Okay, so in second module you'll be learning instruction set and assembly programming and mixed language programming. Third module is about interfacing, so you get a lot of design questions from this module. And in the third module you are also learning some peripheral chips like 8255, 8257. 8255 is programmable peripheral interface. 8257 is so when you want timers, wherever you want timers, 8085 can be used to generate timers. 8257 is DMAC, direct memory access. Direct memory access means it's a peripheral chip which allows your input output devices to directly communicate with the memory. Okay, direct memory access. Then you have the PIC, or this is another peripheral chip 8259, which is called as programmable interrupt controller. So this can be used in case this can be used when you want to increase the number of interrupts that your microprocessor can handle. Interrupts matlab pata hai na, what do you mean by interrupts? See, if I press the keyboard, that is an interrupt which is going to the to my computer, right? So we learn about all these concepts in detail. The third module. Fourth module is about 386. Fifth module, we'll be learning about Pentium, advanced concepts, superscalar architecture, branch prediction logic, Messi protocol. These are all advanced concepts. And in the last module, we'll be learning about Pentium 4. And you can see you have a comparative study of all these processors, 86, 386, Pentium 1, 2, and 3. And then you are also learning this architecture called as net burst architecture. Okay, and then some concepts like translation, look aside, buffer, and hyperthreading technology. All these are involved in increasing the performance and efficiency of microprocessors. So this is what is there in your syllabus. Now regarding the assessment pattern, you all are familiar about the assessment pattern, right? So you have unit test of 20 marks. I'm saying this for there are students from direct second year, okay, who have joined just 2 weeks ago. So 20 marks unit test, 80 marks in semester examination. So total 100 marks assessment, internal assessment 20 marks, and in sem exam is 80 marks, 100 marks for your subject. You also have a lab associated with this subject, microprocessor lab, where you have this oral practical examination. Okay, so provided if things start offline, you may have an offline practical exam. Okay, by then. So here we'll be doing 11, 12 experiments from this list of experiments which are specified in your syllabus. So these are the list of experiments specified in your syllabus. Out of this, we'll be implementing 11 or 12 experiments. Okay. And then the reference textbooks that you can use is also given in your syllabus. I wouldn't suggest any single textbook because most of the concepts are not, it's not there in one single textbook. You can, all these are equally recommendable, but try if you can get a soft copy of Uffenberg. Okay, so this is the standard foreign author textbooks, which is followed all over the world, okay, by university students. So if you could get a soft copy of this textbook, 808688 family, design, programming and interfacing by Uffenbeck, then well and good. This textbook is also available in your college library. So if you want to get a copy, you can come and fetch it. Okay, these are the other additional textbooks. Most of them are available in your college library. Okay? Try if you can get a soft copy of Offenbach textbook. Author name is John Offenbach. So it is very important that you learn subjects using standard author textbooks, because say in future if you're trying to apply for MS, or say you're trying to apply for higher studies in even in IITs or national institutes, most of the times in the interview they ask you, do you know the subject, which textbook have you referred? At that time you cannot mention any local author textbook, they'll just throw you out of the interview. Okay, so you need to be at par with the students across the world, right? Especially if you are trying to go abroad for MS or higher studies. So then it is better to follow this standard foreign author textbook, because uh, the terminologies that you use, the terminologies that are used in a local author textbook and the terminologies that are used in a foreign author textbook will be different, drastically different. So you need to be at par with the students from other countries across the world. So it is always recommendable to learn to read and comprehend standard textbooks. Okay. So apart from going through the notes which are provided by your faculty, try to go through such textbooks. Okay. Go through standard textbooks. Try to read and comprehend concepts on your own. So evolution I've already discussed, right? As I've already discussed. So you can see 8086 belongs to the third generation. First generation came in 1971 to 1973. Okay. And then you have the second generation. 8085 belongs to the second generation. 8086 belongs to the third generation. And Pentium and higher versions will belong to the fifth generation. So I've already discussed this timeline. So from the next session, we'll actually step into the syllabus. Okay. So today's session was just an introductory session to make you aware about why the subject is there in the syllabus, why we are learning it using 8086 microprocessor, and to discuss the course objectives and outcomes. That was the objective of today's session. Okay. Everybody please mark your attendance in the chat window. Please use your updated roll numbers. Huh? You got new roll numbers, right? So hereafter when you are marking attendance, please use your updated current roll numbers.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Hello, ma'am.
Yes, Rishi.
Ma'am, I had a doubt about UT1. Are there going to be questions regarding any C program in the UT?
Just a minute. Let me just stop recording.